Okay, so this is the second video about work and conservation of energy, focusing on the mcat. A few problems, not that many. So here you have one here, and you have a pulley system again. And again, they are trying to confuse you with this angle here, and you might wonder how you're going to use that. But the mass here, they say it's 10 kilograms, and it's accelerating. So this is the object. Now you have an acceleration here, up. The magnitude is 2 meters per second square. So it means that you're going to have a net force up. Okay, so then we decide of what's going to be the system here. So that's your system here. And we're going to look at the free body diagram. So we're going to have the weight here, mg. So the tension here and the tension there, you have T1 and T2. Okay, but if it's the same rope here, okay, there is no reason why one should be larger than the other one. So T1 and T2 will be equals, and they will be equal to F, right? Because the same force is transmitted through the rope here, so you have the same force. Okay, so you're going to have 2T minus mg equals ma. And you need to suppose that those two tensions will be the same, because we neglect the mass of the pulleys, the mass of the rope, and again, it will be the same tension transmitted all over. So that's how tension works, right? It's being transmitted through, and it's the same in magnitude. So we have these equations here, and you can pause the video. So we're going to have 2t minus 100. So let's say g equals 10, equals 10 times 2. So 2t equals 120. So T will be about 60 Newton. So that's going to be the answer here. And they give extra information that you don't need to use. So the trick here is really to define the system. What was the system? That was the system. And then you do your free body diagram. Okay, so let's go to the next one. So just a definition here. Which of the following is a conservative force? So friction or anything that turns mechanical energy into heat is not a conservative force. So a conservative force means there is potential energy. Gravity is a conservative force. Okay, so you have different ways to look at it. The work done from point A to point B is independent of the path. So for example, if you look at gravity, if you go from A to B here, okay, and this is above the ground, so this is the ground here, and this is above the ground. It doesn't matter if you go this way, you just go from here to there, okay. The work done will be the same from A to B, because it depends only on the height. So the potential energy is just mg delta h. Doesn't matter how you go, or you can say B is here. Doesn't matter if you go this way or you go straight from A to B. So that's a conservative force. You can say also that if you go over a closed path, so if you start from A here and you go for a trip, boom, 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 you go back to A, the work done will be equals to 0. Okay, so along a closed path, the work done is 0. And the best way to remember is that there is a conservative force when there is a potential energy involved. So that force here, that conservative force is a restoring force. It wants to bring back the system to its initial position, right? So gravity, for example, it's going to derive, it's a derivative, okay? So it's a derive from potential energy. Okay. So about uniform circular motion. So here they want to make sure you know the definition of a uniform circular motion. Uniform means the speed is constant. That's the meaning of that. So the speed is constant. So if you look at the centripetal force here, you see the speed stays the same, but not the velocity because the direction keeps changing. So it means that you need a force to change constantly the direction. And that force here is called the centripetal force. So in that case, the centripetal force is provided by the tension here. So in magnitude, the centripetal force equals mv squared over the radius, but the speed stays the same. And you see that the force here is perpendicular to the velocity. Okay, so the force here, what it does, it changes the direction, but it does not change the speed, which means there is only a perpendicular component perpendicular to the displacement. Okay, there is no parallel components here. There is no parallel component along that displacement here. So it means that the force cannot change the speed. And if it does not change the speed, it does not change the kinetic energy. So there is no work done. Okay, so the work done by F equals 0. There is no work done, right? Which of the relationship is no work is done? Okay, that's true. The centripetal force does work. That's not true because it's a uniform, so there is no component of the force along the displacement. The velocity does work. No, a velocity does not do work. Only a force can do work. Potential energy depends on the position. We don't know about the situation here. We don't know which type of motion it is. So if it's a horizontal motion, here potential energy will not change, right? And we don't know what potential energy you are talking about. So that's not true. So A is true. So the work energy theorem. So you just need to know the definition of the work kinetic energy theorem. It just says that the net work done on a system equals to the change in kinetic energy. So if you isolate a system, okay, not including the Earth, just the system, and you look at the net force, if there is a net force, then there is if there is a net work done by a net force, then there is a change in kinetic energy. It's going to move faster or it's going to move slower. So it's just the definition here. You can refer to my slides. Okay, so that will be answer B, right? So the total work done on any object is equal to the change in kinetic energy. So if work is done, the net work is done, then there is a change in kinetic energy. Okay, so here they want to make sure that you know. So you have potential gravitational potential energy, and you also have elastic potential energy. So that's part of the things you need to know. And they all want you, they just want to make sure, first of all, you know how to compute. And second of all, you know what's the expression for the elastic potential energy. It will be 1/2 a constant here. And then here, that will be X is how much a spring is compressed or stretched. Okay, so that will be the elastic potential energy. And the restoring force is minus Kx. So it's a conservative force, right? So what's happening here? You have a spring. Let's say here it's happy, it's at rest. And now you start to compress it. 2 centimeters, right? So here it's compressed. Okay, so it means you are pushing on it here, and it's being compressed here by a displacement of 2 centimeters. So it means the potential energy will be 1/2 K then 0.02 square. And now you compress even more, so that will be x1. And then you compress even more to x2. And again, you have to stop the video each time. So this is the rest position, and you are compressing even more, twice as much. Okay, compressing even more. Okay, so you need twice the force, because the restoring force here is proportional to the displacement, and that will be 4 centimeters. So you see there is a square somewhere. That's why the answer is not doubled. So 1/2 K 0.04 square. Right? So if you find the ratio between them, okay, you have like 0.04 over 0.02 square, which is 2 square, which is 4. So the potential energy has been multiplied by 4 here, not by 2, by 4. Okay, so you can pause the video for the next one. It's a little bit more challenging here. So anything that fall, so when an object is in free fall, you are neglecting the air resistance, and free fall up or down. So you throw something in the air or you drop something compressed. Okay, so then we have this one. So you can stop the video. And so this one is a little bit more challenging. So you have Mark and Emily, and they fall from the same height, and we neglect air resistance. So here they start from the same height. So they go down here. They're going to have, so from potential energy to kinetic energy. And then they hit a trampoline. So that kinetic energy will be converted to elastic potential energy, back to kinetic, and back to potential energy. Okay, so if you think of conservation of energy, you go from gravitational potential energy, and then kinetic energy, and then elastic potential energy, back to kinetic energy, and you go back to the same situation. Okay, so if there is no air resistance and there is no loss here, they will both go back to the same height because of conservation of energy. The other thing is that they are both in free fall. So in free fall, the mass does not matter, right? So when something is falling, we always have this relationship here. So the mass does not matter. So we're going to see that. So which one is not true? So is it true that the energy is converted from potential to kinetic to elastic to kinetic? So here it's going to be kinetic here. Sorry, here it's going to be elastic, and then back here to kinetic, and then back to potential. So is this true? Yes, it's true. Mark will experience a greater force upon impact than Emily. So what's going to happen when they both hit? They're going to both hit the trampoline. First of all, they're going to both hit the trampoline with the same speed, right? That's because of free fall. So if you have a mass, let's say you have AT and potential energy. So AT G times the height, which is 20. Okay, and I want to know what's going to be the final speed here. So the final speed will be, so you have the kinetic energy and then V squared. So you see that the mass does not matter. That was from Galileo. Regardless of their mass, anybody all the bodies will have the same acceleration, and when they hit the ground just before they have the same speed, you can see that V squared here will be, so this is 110 times 20 times 2, which is 400. So the final speed for both of them will be 20 meters per second. And then they will be acted upon by a restoring force, right? So the trampoline is going to push on them. Okay, so the force, and it's not a constant force, but imagine, so the force, the average force, right, times the time during which they are in contact with each other will be the mass times the change in velocity. So the change in velocity will be the same for both, right? Because they start here with the same speed and then they stop. And then what's going to happen? The mass here is larger. So the force here will also be larger, or the impulse will be larger. Okay, so of course, Mark will experience a greater force upon impact. That will be true, because remember, force equals the mass times the acceleration. So if you have a large mass, you expect a large force. So it needs more force for the trampoline to stop Mark than to stop Emily. So that will be true. Mark, the change in speed from the start of the jump is 20 meters per second. That is true, because you see here the final velocity is 20. You start with velocity of 0. Okay, so the change is 20, so that is true. Does Emily bounces higher than Mark? That is not true, because of conservation of energy. If you start from here, you go back to the same height. You cannot go higher unless there is an input of energy on the way. So which statement is not true would be A. Okay, so it's not that. This one maybe was a little bit tricky. They like tricky questions sometimes. Okay, so the skydiver. So this one, you can stop the video. Which one is true? So you have a skydiver and she reaches terminal velocity. So what does it mean? Terminal velocity, it means that it's in dynamic equilibrium, right? So it means terminal velocity, it means that the velocity is constant. So it means the net force is 0, right? So it means air resistance is up. So this is air resistance. And then you have the weight down, and they are equal to each other. Skydiver est translational dynamic, or equilibrium. So yes, this is equilibrium, and at the same time it's moving, but it's moving at a constant speed. is not being acted by any force. That is not true. There is an equal amount of work being done by gravity and air resistance. That is true, because work is the force times the displacement. The force is the same, displacement is the same, so the work done will be the same in magnitude. So that will be 1 and 3. Okay, this one, they don't talk about the sign, but this one is doing negative work and this one is doing positive work. So it's not very clear. Okay, let's do the next one. So mechanical energy. Okay, let's take a look at this one. You can pause the video here. So twofold means multiplied by 2, right? So the mechanical energy is the sum of kinetic energy plus potential energy, and that stays the same if there is no friction or no air resistance. So in that case, if the potential energy increase by a factor of 2, so this one need to be divided by 2. If one is multiplied by 2, the other one is divided by 2. No. Let's see, because there's a plus here. The kinetic energy has diminished by the same amount as the potential risen. No, that will be the answer. So the answer is C. Okay. Okay, so that means if this one is plus something here, so then you have to do minus here to get the constant, because here you have a plus sign. So sorry, kinetic energy. Okay, so this one also was a tricky question. So the answer is C, because there is a plus here. So if you add to this one, you need to subtract from that one by the same amount. Okay, so this one also is a little bit tricky. So you can pause the video and think about it. So when you have power, so average power will be the force times the average velocity. So more power for the same force, you can get more velocity. And also power is the change, for example, in kinetic energy over the time. So it means the power for a car is how fast the car converts energy, right? From the fuel, from potential energy to kinetic energy. So that's not possible. Unlimited speeds. Nothing has unlimited speed because of the engine and because of the fuel. You always have a limited amount of fuel. So which one has more power? That will be B. B has more power. So we might go for D. Okay, so it means the one with more power will have a more maximum speed, right? Because it's going to convert energy quicker, so it's going to go faster. It's going to go faster, quicker. It takes less time to go really fast. Okay, so that will be D. Lose energy? No, it depends on how efficient the car is, right? Or how it is designed, so it depends on the design. Okay. Also, kind of tricky question. Okay, so the last one is this one. Although it's, I think it's not very well worded. So you can stop the video. So they talk about mechanical advantage. So mechanical advantage, it's when you have a machine, right? So for example, if you take a lever here, you have a fulcrum, that will be your load. Let's say this is 1, and that will be 1, 2, 3. So here you push, and this is called, sometimes it's called the effort, but let's say I call that the input, right? The force input. And that here will be the output, right? It's the weight of the load. So the mechanical advantage in that case, it will be 3. Okay, so it's the output force over the input force. So it means you are 3 times as strong. But there is a price to pay. If this one lifts by 1, you have to push that by 3. Okay, because of conservation of energy. So work out should be equals to work in if there is no loss. Okay, so first of all, mechanical advantage, I know what it is. It's forces, okay? So yes, so that will be B, and it's the only one. Efficiency, they are not being clear. Efficiency, how efficient is a machine? It means that not too much loss to heat happens. So efficiency usually it's work out over work in. Okay, so if there is no loss to heat, that will be equal to each other. But that's what we call efficiency. And in that equation, they call that effort, which is confusing. So that should be work. Okay, so that's it for this series.